Thanks for the opportunity to speak with you folks. What we want to do is basically just give you a little bit of insight and an overview of API's efforts to create an industry standard in terms of how cracks are managed within the pipeline industry. All right, so just to put it in context, if we just look historically, and we're looking over about a 15-year period here, the industry's done a significant and positive effort in terms of addressing corrosion incidents and third-party damage. Okay, those have gone down significantly over that period of time. The gap that we need to chase, though, is cracking. And again, there's two elements here in terms of cracking. There's environmental cracking, and then there's cracking associated with residual manufacturing defects, okay? So the graph that you see there is focusing on the manufacturing defects, but the RP addresses the broader element of cracking. So the genesis of this was basically a strategic initiative outlined by the API executive asking the technical committees to produce the deliverable to provide that industry guidance. There's broad engagement where you're looking at 20+ companies were directly involved in creating the technical content. To both support the elevated or escalated timeline that we're looking at, in other words, we wanted to get this out as soon as we reasonably could, but also to address that peer review component, Kiefner & Associates was engaged as the primary consultant. And there was quite a number of individuals within Kiefner & Associates. Again, you'll see shortly, and it's kind of alluded to that there's 5 subcommittees. Again, we broke out into teams and concurrently developed elements of the RP in order to expedite that timeline. The other aspect here is that we weren't starting from scratch. There's a significant body of data within the industry as it relates to crack management, but it was disparately organized. In other words, there were some documents that talked about how you manage, stress corrosion cracking. There was other research papers as it related to manufacturing, right? And what we wanted to do was basically compile that spectrum of information into one source that could easily be leveraged by the operators or the industry, if you would. In terms of the scope, this API document was a little bit different because what we wanted to do was kind of step back, and there's 2 things in particular I want to highlight here. One, the document was designed for both liquid and gas pipelines, okay? One of the considerations of that is a lot of the industry operators out there operate both types of assets, right? And it becomes problematic both from a regulatory oversight perspective, but also from an operator perspective if you have disparate technical guidance in terms of how you're going to do it in liquid, how you're going to do it in gas. The other thing that we addressed here is it was a very technical approach to the content. In other words, the content of this RP is designed to be applicable in different jurisdictions, okay? It wasn't specifically targeting PHMSA regulation in the US, okay? It was more fundamental principles. How do we manage this threat no matter where that pipeline is located on the planet? Lastly there, the focus of it is basically on the right-of-way. In other words, the pipeline that's buried on the right-of-way. Now, a number of these elements can be extrapolated over to facility piping, but that's not the primary focus of the RP, so just keep that in context. From a philosophical approach in terms of how we proceeded, unlike the leak detection document, this is not designed to be a programmatic document, okay? Your integrity management program that addresses the spectrum of threats, that's where your programmatic elements are contained and addressed. And that would be, for an API perspective, API's recommended practice 1160, okay? This document was more focused on the technical considerations as an augment to your broader integrity management program. I alluded to earlier, we're addressing the various different types of cracking threats. It needed to be flexible, and the last 2 elements kind of feed into that flexibility. In other words, you're going to have operators that have extensive experience managing the crack threat. And they've got an enormous body of data they can draw upon. And then you've got operators got very little experience with it, and they're just getting into that. And so we tried to create the flexibility that it provided sufficient guidance and raised the bar. So for the operators that don't have that knowledge base, it gives them clear direction. But for the operator that has an extensive body experience he can draw upon, he can leverage that experience and expertise to basically architect his program to be optimal for their assets based on their experience. And part of that is basically data integration. Now, there's other initiatives within API that get into the meat of data integration, but it's threaded throughout this document that you have to understand all the relevant data that's available to you and how that data interrelates and the synergies in that data so you can make informed decisions. I alluded to that we had 5 teams. Here's a quick overview. I won't belabor what the team structure is in that, but just to be aware that one thing this provided, other than expediting the timeline, is it provided a broader level of engagement. In other words, we stood up the various teams. It maximized the input from the industry to give us as best a representation across the industry in terms of what was available and what were the best practices. This just gives you a quick high level. And we're going to take a couple of different cuts in terms of the content of the document, and then I'll do a deep dive here, but I'm trying to motor along to get you guys back on time here. So the first thing is basically getting into the SEC and environmental cracking, and that was the group that I led. And so again, what you're talking about there is basically there's an environmental component that's creating that cracking environment, and it can be exacerbated or made worse, if you would, by cyclic fatigue, okay? And so that's where you see the differentiation between the liquid and the gas lines and how that plays into it. Also got into basically giving insight and direction in terms of what tools are in the toolbox, if you would. You have hydrostatic testing, you have inline inspection. What are there's a plethora of technologies out there that you can use for crack detection as it relates to inline inspection. Some have more or less strengths for different types of features. And one of the key elements of the document was to basically educate the operators in terms of what's our current state of knowledge in that regard. Hydrostatic testing, as I alluded to, there's actually another API initiative specifically targeting that with a guideline. So we don't get into a huge amount of detail in here, but we do introduce the considerations of when you might be interested in the spike test, when the spike test is more relevant. But much of that material is to reside within that guideline yet to be released by API. Quick table of contents, and no, I'm not going to talk about all of this, right? Just to give you a sense of the breadth of what's actually getting addressed within the document. And as I allude there on the right, it is 160 pages plus. So there's a significant body of content there. And then even beyond the core sections of the document, we get into the various annexes. And this is where we do a deep dive into some of the elements. Case in point, just basically, and I'll come back to this later, on Annex E, the toughness. And so when you're dealing with the cracking threat, and this will come up again throughout the presentation, it's not as straightforward and simple as you would with corrosion. Okay, corrosion, one of the essential variables is the yield strength. It's unequivocal, it's one number. For toughness, the number that you use depends on the methodology that you're applying. For instance, if I'm on a gas line and I'm actually trying to arrest a crack, in other words, stop the crack from running, I resolve the toughness one way. If I'm looking at initiation of that crack's running, I assess it a different way, okay? And so you're going to see that there's a lot of complexity to make a fully informed decision on managing the crack threat, and that's the focus of this document, is to outline those complexities and provide guidance for the interpretation. But in a number of cases, it's not definitive because it changes depending on your circumstance. Again, looking at the ILI data a little more in depth here, just to take a deep dive into section 11, we talk about, again, I alluded to this earlier, what the tools are, how they're applicable, what their strengths are, what their weaknesses are, what are some of the considerations. And in the latter part there, the key element is how you validate that tool technology on your system, okay? So when you run the tool, it gives you a certain insight in terms of what's going on. But now you have to do those correlation excavations and validate that is what the tool calling and identifying accurate and applicable in your context. And again, it does vary for the different mechanisms. In other words, we talked about manufacturing defects that grow through fatigue versus environmental cracking, and even different steels, right? And the orientation of those cracks will give you different feedback from the tool sets. Regarding crack response, and this is basically how you respond to that ILI data. Essentially, it's a balance between two elements. You want to be able to achieve an equivalence to corrosion. In other words, it's clearly understood how you're going to respond to it. It's a prioritized response based on the severity of that feature. But the problem that you have with inline inspection tools, and this is a key consideration in terms of the potentially being overly prescriptive, is that certain feature types for crack tools have an inordinate number of false positive calls. By that, what it is, the tool thinks it's a crack, but it isn't actually, and it's a non-injurious feature. And so to give you an example, on the same line running one tool, one feature type might be a real crack that's injurious 9 out of 10 times. Another feature might only be injurious 1 in 10 times. So your response is going to be different for those two feature types, even though they're both called by the same basically crack tool. In other words, an inline inspection tool designed to identify cracking features. Okay, so let's just get into the meat of it and let's talk about a crack response criteria. So if we look at basically what's in 195 today and what's in 195 in the proposed notice of potential rulemaking, there's a criteria in there that a potential crack indication when excavated is determined to be a crack, okay? And again, in terms of industry document, specifically targeting regulation, that same criteria ended up being embedded in 1160, okay? The problem with that criteria is it gives you no assessment or prioritization guidance. Okay, so let's look at it. I ran an inline inspection tool and the criteria tells me it's a crack after I've dug it up. It doesn't give me any direction as to what cracks I should actually dig up, okay? The other aspect is, if you basically interpret that, it would indicate that no crack is meritorious of an immediate response, okay? And that's not what was intended, but essentially that's what we ended up with in terms of a criteria. So this is what's in the RP in terms of an immediate response. And I kind of paraphrased it a bit just to keep it light, but essentially trying to draw that equivalence to cracking. Now in this case, we basically set a depth criteria of 70%. That's actually more conservative than the equivalent 80% for corrosion. Similarly, from a failure pressure ratio, and what that is basically it's the ratio of the failure pressure of that crack as assessed relative to your maximum operating pressure or maximum allowable operating pressure, depending on whether you're liquid or gas. And that basically we stipulated to be a 1.1. And again, more conservative than existing 195 regulation, but that is aligned with the proposed notice of proposed rulemaking. Okay, so in both these cases, it's understood as we exist today in the industry, there's assumed to be a greater level of uncertainty in terms of how the inline inspection tools are seeing the cracking features, and that's why both those thresholds were set as being more conservative than corrosion. But again, it gives you clear direction in terms of, based on what the tool's calling, how you would respond to it in terms of a prioritization. Okay, from an overall crack approach, again, I won't belabor it, I'll just touch on it real quick. Again, it's flexibility, right? Some operators have done tens, if not almost like 100+ inspections for cracking using inline inspection technology. They've literally done thousands of excavations, right? This is basically taking that data, pulling it together, and letting them make an informed, targeted program in terms of how you respond to that. So one of the approaches that the document takes is basically this delineation of likely, possible, and unlikely as it relates to ILI features. And again, I harken back to the example I gave earlier, where if 9 out of 10 times that feature is a real crack, it's going to be likely. There's no real interpretation. You respond to it as if it's a crack, right? If 9 out of 10 times it's not a crack, it's non-injurious, right? But it has the potential to be a crack, you are going to go investigate those. But given the volume of those features, you have to treat them with a more measured response, right, in terms of the resources that you have at hand. Unlikely crack feature would be a feature that it's seen by the crack tool. It's typically not, I mean, basically, you have no experience of it ever being identified as a crack. In other words, you dig it up, it's non-injurious, but it's getting called by that technology. An equivalence to this would be if I ran a magnetic flux leakage tool looking for corrosion, and it called metal in proximity. Basically, metal's buried near the pipe. That's an unlikely corrosion feature. You wouldn't treat it as a corrosion feature, but you want to be aware of it in case there was some odd situation where it was actually a corrosion feature, but it ended up getting mischaracterized, okay? So you need to keep your eye on those in terms of taking the opportunity to investigate those when they're in proximity to otherwise planned excavations. And then just even getting into the length of the feature. Again, I won't go on this ad nauseum, but it gives you a sense that in terms of fatigue growth, both the C and N are essential variables in terms of calculating how the crack would go. There's no one universal right answer. It depends on your circumstances. Stress corrosion cracking, again, it gives you direction in terms of the susceptibility. Understand that only a very small portion of the pipe buried in the ground in North America is actually susceptible to stress corrosion cracking. This gives guidance to how you delineate that, right, and where it's appropriate and not appropriate to actually leverage those tool sets. We also talk about in-ditch techniques. And again, this is critical in terms of being able to correlate the performance of what you're finding or determining the performance of the tool by correlating what you're finding in the ditch versus what the tool predicted. The timeline, we started this in 2014. Did a first pass for the key stakeholders just to get validation of the structure and format. It was balloted this past May. We had hundreds of comments come back from the individuals that were engaged in the balloting. It was really positive in terms of the level of engagement that we did get, but what that means, it took quite a while to actually resolve that. We just resolved that, but given the breadth and the volume of those comments, it's going to be reballoted again. So now you're looking at late Q1, early Q2 when that actually gets released by API. And then lastly, just looking forward in terms of implementation strategy. Again, with the current methodology of API, it's not just create the document, huck it over the fence, hope you know what to do with it, right? There's a conscious and concerted effort to engage the industry in terms of how to facilitate the uptake of this document so that it materially impacts the operators' programs and they know how to leverage it within the context of their broader IMP. Thanks very much. Appreciate it.